Let's talk about examples of epsilon delta proof of limits. We already have an example on the screen, but before we solve this example, there are some key ideas that I want you to understand. Now, in the epsilon delta proof, there are two variables that we're mainly concerned with. We are concerned with the epsilon and the delta variable. Think of the epsilon delta proof as kind of like a game. So you have two people. Let's say this is me and this is you. The idea in the epsilon delta definition is, say I give you an epsilon value. An epsilon could be any value. It could be 0.5, 0.6, 0.7. But since we do not know the value, we call the value epsilon. Now, you're expected to take the epsilon value and provide me with a guess. Okay, so the guess that you're providing me is the delta. Now, I am now to verify whether the guess is true. So I'll verify your delta. Watch the steps that this happens in. Now, for all of this process to happen, there are two key inequalities that you need to take note of. The first inequality you need to take note of is f of x minus L, and then an absolute value sign is less than epsilon. And then the second inequality you need to take note of is x minus a. They have an absolute value around them, less than delta. Now, if you want to really know how these inequalities came about, I'll leave a link to another video here so you can easily understand what this means. But since we are solving examples, I'll be going straight to using them. So for this first step on me giving you the epsilon, what would happen is that for you to derive your guess, for you to be able to guess delta, you have to take this inequality and convert it to this inequality. So use this to guess delta. So when you finish guessing the delta and you give me back your delta, in order for me to verify your delta, I'd have to use this inequality and convert it back to this inequality to verify. So that's just the two simple steps involved in proving limits. Let's quickly use this example to solve it, since all of this is kind of getting abstract. Now remember, I said you solve this in two steps. So step one, you find delta depending on epsilon. Now to do that, you simply take this inequality and convert it to this inequality. So how do we know the f of x and the L and the rest? Now, a typical limit is written as limits as f of x as x approaches a is equal to L. If you liken these terms here to these terms here, our f of x is this, our L is this, our a is this. So if you're going to write this inequality, write it as absolute value of 3x plus 1 minus 7 absolute value is less than epsilon. So if you simplify this, this becomes absolute value of 3x plus 1 minus 7 is minus 6 less than epsilon. Remember, the goal here is to find delta depending on epsilon. And to do that, we have to transform this inequality to this inequality. If you look at this inequality, if you write it out here, it looks like this. The absolute value of x minus the a value here is 2. So this is a less than delta. So this is the inequality we should be aiming for when we are dealing with this side. What we are aiming for now is to try to make this absolute value term look like this absolute value term. From here, if you notice, we can factorize 3 so that we have 3 absolute value of x minus 2 is less than epsilon. We divide through by 3, would have x minus 2 is less than epsilon over 3. If you notice, this absolute value term here looks like this absolute value term here. So we've succeeded in transforming this one to this one. Now the guess is that if you liken this one, epsilon over 3, to this one, the guess is that delta is equal to epsilon over 3. You've done the first step correctly, which is to give me a delta depending on epsilon. For the second step, I'll be cleaning up this space here and leave out this space for explanation purposes. So for step 2, if you notice from step 1, our delta is equal to epsilon over 3. So from here now, we can take this inequality, you can start from this inequality, so that we'll say absolute value of x minus a is less than delta. This implies when we plug in the term that we have x minus the a term here is 2. So this is 2. You have the absolute value on everything is less than. We bring the delta term that we proved. So from the step 1, we know that our delta is epsilon over 3. We plug it into this place. So this is epsilon over 3. From here, I can say this is absolute value of x minus 2 can cross multiply. So this is less than epsilon, and I have 3 here. If I multiply 3 by the absolute value terms here, this is 3x absolute value minus 3 times 2 is 6. It's less than epsilon. The aim here is to transform this one back to this one. So we are looking to make this term here look like, the one here. So if you look at this term closely, you have absolute value of 3x plus 1 minus 7 is less than epsilon. Okay, so we are looking to make this one look like this one. Because we are looking to make this one look like this one, you can rewrite minus 6. So minus 6 can also be absolute value of 3x plus 1 minus 7 epsilon. So from here, we know that this term here is f of x. This term here is L. Okay, so this is f of x. All of this implies that f of x minus L is an absolute value less than epsilon. Absolute value of this whole thing is less than epsilon. Let's take extra examples for you to understand better. For this one, you can pause the video and try to solve it yourself. So like we did before, the first step is to find the delta depending on epsilon. To do that, like I've said before, you bring in this inequality, f of x minus L, absolute value of this less than epsilon. You plug in the terms from here. So your f of x term is this. So this is absolute value 2x minus 1 minus the L term is this one. So this is 5 less than epsilon. From here, you can simplify the term in the absolute value. So this is 2x minus 1 minus 5 is minus 6 less than epsilon. The aim of this portion of it is to transform this inequality to look something close to this. X minus a is less than delta. Now you can do that by factorizing 2 out of this inequality. So this is 2, and then if you factorize 2, you have x minus 3, absolute value less than epsilon. Now this is x minus 3 is less than, if I divide both sides by 2, I have epsilon over 2. So from here, this part or this portion of the inequality looks like this portion of the inequality. So I can now say I will let my delta equal to epsilon over 2. Step 2 is the formal proof. Just like I did in question 1, I'll start from absolute value of x minus a is less than delta. This implies that x minus, now the a term is the term that the limit is approaching. So this is a 3, then less than. Now remember, our delta is epsilon over 2. So this is epsilon over 2. If I cross multiply from here, I have absolute value of x minus 3, and then I have 2 here. So this is less than epsilon. If I use this 2 to multiply all the terms in this absolute value, I have 2x, absolute value of 2x minus 6, absolute value less than epsilon. Now remember, like before, our aim is to make this inequality look like this one back. So I can rewrite this to look like 2x minus 1 minus 5. Now remember, 2x minus 1 is the f of x term. So this is f of x minus L. So this is minus L and then less than epsilon. So we've arrived back to the original inequality. So that's how to do epsilon delta proof. If you like the video, leave a thumbs up, subscribe to the channel, and share with your friends. Thanks for watching again.